we're going to look at our test corrections, and I'm just going to kind of give you some things to help you. I'm not going to do all of them for you, but I'm going to steer you in the right direction on your problems. Okay, so on number 1, we're going to start on the multiple choice. So on number 1, we have a redox reaction has an equilibrium constant of 2.6 times 10 to the 5th power. That is a huge K, right? K is greater than 1. In fact, much, much, much greater than 1. So what do we know? This is just kind of a memory thing. You had to memorize some things about E of the cell and delta G. And if you don't have that in your memory bank, you got to get it there, okay? That's going to show up on your next test. Because on our next test, we're looking at a real comprehensive exam. Even though it's going to be acids and bases, it's going to have like everything on it. So here we go. E of the cell. E of the cell has to be positive in order for K to be much, much, much greater than 1. You remember making a battery because you have reactants that have proceeded to products, and pretty much you have nothing but products whenever your K is that big, and that means that delta G is negative, okay? So you find the one that matches up to that, and number 1, the correct answer is C. You need to explain that correct answer, like why is that correct? Okay, number 2, we're looking for which of the following expressions is correct for the maximum amount of copper in grams that could be plated out by electrolyzing copper chloride for 16 hours at a constant current of 3 amps. Now, I try to tell you guys to change amps to camps. So camps would be coulombs over seconds. 16 hours has to be converted into seconds. So if I'm thinking of my dimensional analysis here, I've got my 16 hours, and I'm going to put 1 hour over 60 minutes, but I don't even want to do that. I want to put that over 360 seconds to make that faster. So far, let's look and see what we can eliminate. Oh, looking at D, I don't see 16 over or multiplied by 3,600. So D is out of there, okay? Next, we're going to need to, we got rid of hours. Now we can get rid of seconds by using the 3 coulombs per second. So 3.0 coulombs in 1 second. Seconds are gone, so make sure that we have 16 times 3,600 times 3. That one has it, 16 times 3,600 times 3. Okay, so far, all of them have that. Can't eliminate anything else. Now we need coulombs, coulombs to get canceled out. So we've got that even given to me in the problem. That's really coulombs per mole of electrons, and that's on your equation sheet if you needed that. So I'm going to put 96,500 on the bottom, and moles of electrons for every 1 mole of electrons on top. And so coulombs are going to cancel out. So which of these has 96,500? Well, they all have it on the bottom. So far, can't eliminate anything else. Okay, now we've got to get rid of the moles of electrons. So look at what we're electrolyzing. We're electrolyzing copper chloride. The copper is a 2 positive in this particular reaction. So that's 2 moles of electrons for every 1 mole of copper that gets plated out. Okay, so I need to divide by 2, and the only one that has 2 on the bottom happens to be B. Now I could keep going because the molar mass of 63.55 is going to be my next thing that I put in there. For every 1 mole of Cu, I need 63.55 grams, and you can see that that's actually on top of this one, but I don't have the 2 on the bottom, and it's on top of this one, and it's on top of all of them. But that dividing by 2 was real crucial in that question to get that one right. All right, number 3, a redox reaction has an equilibrium constant. Again, this is a huge value, right? I feel like this is pretty much the same question that we just did in number 1. Oh, so if you missed number 1, it looks like you're going to miss number 3. Hopefully not. Let me save this. Okay, so sorry about that. Okay, so we've got the same question. K is greater than 1. E is positive. Delta G is negative. Those are just facts. All right. I know y'all have heard that, just facts. Those are some facts that you got to know. All right, moving on to question number 4. Now, this was a very reedy question. You had to really pay attention to the reading, because this one could, 4, 5, and 6, could have tripped you up by not reading it as closely as you needed to read it. Okay, so the question is asking about what is the thing that's labeled B? Okay, well, I'm looking at B, and oh, that's the salt bridge. So it looks like that structure B is not going to function to complete the electrical circuit, because salt bridges don't do that. So it says provide soluble anions that migrate to the anode, as well as soluble cations that migrate to the cathode, thus maintaining a balance of charge in the electrolytic cell. The anions do migrate to the anode. The cations do migrate to the cathode. But it also says that in C. Here's the tricky part. That one says electrolytic, and this one says galvanic. Remember that an electrolytic cell is not a battery. It needs a battery. And a galvanic cell is a battery, and that's what this is a picture of. So if you didn't read that carefully, you would have missed it if you just read B. Yeah, I don't really care for that question either, but that's just how that one rolled out. So C is the correct answer due to the difference in that terminology. And notice that D, it says anions migrate to the cathode. That's not true. Anions migrate to the anode. Cations migrate to the cathode. That's an easy way to remember that. Okay, number 5, we're looking for A. A is an electrode. And why is it the cathode and not the anode? Well, if we look back up here, we know that fat cat means that the electrons are always going to be flowing from anode to cathode. That's what that means. So this would be my anode, like this young person labeled anode, and she labeled this cathode. So she had it marked already correctly on her paper, and notice that she marked the correct answer was C. Electrode A is the cathode. It gains mass since metal ions are being converted to metal atoms, which often adhere to the electrode. That is correct. Now, if you look at A, it says electrode A is the cathode, but O is the anode, which is not. Okay, and then B is not even an electrode. So you could eliminate a couple of those just from that part. Okay, and then which of the following best describes the electrochemical cell? So she's already got this one labeled since she already has A is the cathode and C is the anode. So she picked electrode C is the anode. That is correct. And electrode A is the cathode since the current always flows from anode to cathode. Correct. Fat cat. Okay. Make sure you're stopping and explaining these, so feel free to pause this video as much as you need to figure that out. Now, on number 7, I should have given you credit for either, let's double check and see what this asks. It says, which of the following mathematical relationships is represented by the letter B? So if I'm going from E of the cell to K, or from K to E of the cell, I can use, really, I need to use C, but why did I circle B for hers? You can also use B. So if you put either B or C, I should have given you credit on that, and you should have that, a reflection of that on your test. For instance, I'm looking at this person's test, and he put C, but I gave him an OK, and so he got an extra number added to his total, okay? All right, so 7 I would say B or C would be fine. Okay, and then number 8, which of the following mathematical relationships is represented by the letter A in the diagram? Okay, so I'm going to A, and I'm going from E of the cell to delta G. E of the cell to delta G, honestly, A would be your best choice, and I didn't give you any credit. Those are pretty easy questions, to be quite honest with you, I think, on that. Number 9, moving right along. So we had 11 questions. No, we didn't. We had 14. Okay, number 9, consider the electrochemical cell pictured above. The thermodynamically favorable reaction that occurs when the cell operates is this. Which of the following occurs once current is allowed to flow for 5 minutes? It doesn't matter if you allow current to flow for 5 minutes, for 2 minutes, for 1 minute, for 30 seconds. As soon as you start allowing current to flow, if you're always going from anode to cathode, but Ag positive is going to decrease And CD positive 2 is going to increase because this reaction is flowing from left to right. So if you're increasing your products and you're decreasing your reactants, the voltage will actually decrease. Okay, you could plug that into the Nernst equation and prove that just by simply crunching some numbers. You could show that the cell potential is decreasing as that reaction proceeds. But just understanding that as soon as you start running this reaction, silver ions are decreasing, cadmium ions are increasing. So kind of, if you think about this, it's like you're increasing these, you're decreasing these. And if you think about shifting your reaction is kind of shifting back to the left. Not kind of, it is. It's shifting to the left. And that's going to cause the cell potential, the voltage to decrease because you're moving your reaction a little bit back to the left. Number 10, which of the following occurs if 50 milliliter sample of 2 molar cadmium nitrate is added to the left beaker? So this is exactly the same question that we had at number 9, except that you have an amount. So if you look back up at your picture, the original amount was 1 molar, and the original amount of silver nitrate is not changing. It's still 1 molar. So I'm going to put numbers underneath or maybe above. I have 1 molar of silver ions, and I have 2 molar of cadmium ions. So I'm increasing my cadmium, therefore the reaction is shifting back to the left, and anytime I shift the reaction back to the left, voltage is going to decrease, okay? It's just a Le Chatelier's shift. Okay, number 11, an electrolytic cell. I don't like how they said that. An electrolytic, that's a typo, and I think one person caught that. It should be an electrochemical cell based on the reaction represented above was constructed from zinc and copper half cells. The observed voltage was found to be 1 volt instead of the standard reduction potential of 1.1 volts. Which of the following could correctly account for this observation? So we have lower voltage, okay? It has nothing to do with the size of the electrode. It does have to do with the difference in concentrations, okay? Volume is not going to deal with that. Your concentration can still be the same if you have different volumes. It's just like, well, I only put 50 mils in this one, and I put 100 mils in that one, but they were the same concentration, so that doesn't matter. And then the zinc solution was more concentrated than the copper solution. Let's think this through. If zinc, this is back to Le Chatelier's principle, let's say zinc was a 1 molar solution and copper was only a 0.95 solution. Which way is that reaction going to shift? That is correct. It's going to shift to the left. Therefore, the voltage will decrease. Okay? So it's all about concentration of solutions. Why is it not B? The zinc electrolyte was zinc nitrate, while the copper electrolyte was copper sulfate. Both of those would probably be, there would be spectator ions, and it's not going to matter. You still have copper ions, and you have zinc ions. Okay? So it's all good with that one. Okay, moving on. Number 12. Which of the following, first of all, I need to read all this other stuff. And so looks like she's got a lot of things already marked up here. A student wishes to construct a thermodynamically favorable galvanic cell. So that's telling us 2 things. That tells us that delta G is negative and that E of the cell is positive. Okay? She's trying to make a galvanic cell. Has to have E of the cell positive. It's thermodynamically favorable. It's going to work. So she's using the electrodes of chromium and silver. So we pick out chromium and silver from our little table up there. Each half cell will consist of an electrode partially submerged in 1 molar solutions of its nitrate salt. 2 electrodes will be connected by separate wires to a voltmeter, and 2 half cells will be connected by a salt bridge. Okay, basic stuff. We're dealing with a galvanic cell. So we've got our 2 numbers up there, and remember that these are reduction values. It says it right there. So one of these is going to have to flip to give us a positive E of the cell. So if I flip which one? Yes, that's correct. I'm going to flip my chromium, and that's going to make that a positive 0.73. And when you add those 2 numbers together, you end up with the correct answer of C, 1.53. Okay? All right, number 13, which metal serves as the anode? Now, the thing is, which one did we flip? We flipped the chromium, that's right. And so hopefully you caught this little thing in class, as I said it a few times, flipping anode. Okay, the anode is the one that's going to flip. And so you flipped it, therefore chromium is your anode. Now, we have to make sure we pick it out correctly. We're looking for the anode. And so not silver, and then chromium. Since reduction takes place, what happens at the anode? Anox happens at the anode. So oxidation takes place. So D is the correct answer. Number 14, the student constructs another galvanic cell still using silver and chromium electrodes, but substitutes a 0.5 molar solution of silver nitrate for the 1 molar solution of silver nitrate in the silver half cell. Which of the following best describes the effect? Okay, I like to write my equation when I'm dealing with these. So I flip the chromium. So chromium looks like this. Cr yields Cr 3 plus 3 electrons. Okay, and I'm mixing that with silver, Ag plus an electron goes to Ag. Now, when I add these together, I actually am going to need to multiply this one times 3. So I will have chromium plus 3 Ags. Can't see that. There we go. My electrons are going to cancel out because I have that 3 will distribute. Yields chromium 3 positive plus Ag. Okay, so that's my reaction, except I forgot to balance it. There we go. 3 Ags. Okay, so there's my reaction. Now, I am changing the concentration of this one. This is now 0.5 molar rather than the standard amount, which is 1 molar. Didn't say I'm changing the chromium, so it's still a 1 molar solution, but the silver nitrate has been back down to a 0.5 molar solution. Which way is this reaction going to shift now that you have the reaction written out there and numbers underneath it? You have a greater concentration on the products, a lesser concentration on the reactants. So you're correct. It's going to shift to the left. Therefore, voltage will decrease due to fewer reactants present. Okay? All right. It's not decreasing in both cells. It's just decreasing, okay, due to fewer reactants being present. Okay, sorry. I was trying to flip to the next page. Let's go to the open response. And I tried to make these not so grievous on you, and I hope you did well. Oops, I'm showing whose test that is. Kylie did a good job, by the way. So let's look at, I'm going to have to change this a little bit so we can see that, all of it, not that much. Okay, I need a little bit more. Okay, so here we go. That's way better. Okay, respond to the following statements and questions that relate to the species and reaction represented above. So we've got the reaction already balanced for us. The diagram shows a galvanic cell based on this reaction. Assume the temperature is 25 degrees Celsius, which just simply means everything is under standard conditions, okay? So we have 1 molar solution, 1 molar solution. Notice Kylie, she labeled the anode and the cathode. Why did she do it that way? Because she knew fat cat from anode to the cathode. And actually, she knew it that way because she went down here and looked at her E of the cells because she had to draw that on there. Okay, so here we have the information that's given to us. Given the information, determine the value of the cell voltage. Which one's going to flip? You're right, aluminum's going to flip. So we flip that one, and so we would have 1.66 minus 0.76. And some of you struggled with the math. You have a calculator on this. The correct answer on the voltage is 0.9 volts, okay? So you just simply flip what you need to flip, and you're going to subtract. I had some of you that put 1.1 volts, and guys, you have a calculator. Indicate where the value of the standard free energy delta G is positive, negative, or 0. If E of the cell is positive, then delta G has to be negative. Now, I want to know, I don't know if you got full credit on that one, because you really need to, even if you got full credit on that one, you need to show some work besides just showing this little memory. You have an equation, delta G is equal to minus none B. You could calculate that, and that would be a better answer than just saying E of the cell positive, delta G negative, okay? It would really be a much better answer if you showed, prove it, using that equation. Plug in your value for E. Faraday's constant goes here, and the number of moles of electrons would be 6, because look at your electrons. You've got 3 and 2. 3 times 2 would give you 6 when you write that balanced equation. Okay, in fact, the equation is already balanced for you. So 3 times 2, 2 times 3, there's your 6 electrons. Okay, so I'm just using that equation to come up with the reason why delta G is negative. And remember, that's a minus sign in front of that. If the concentration of aluminum nitrate in the aluminum/aluminum 3 positive half cell is lowered, oh my goodness, it's again just like it's like the same question keeps coming back to haunt us. So if you didn't know that, I guess it could kind of get you in several places. We're lowering the concentration from 1 to 0.01. Okay, so zinc is not changing. It's still 1, but the aluminum is 0.01. Now, which way is that reaction going to shift? It's going to shift to the right. Is cell voltage going to increase, decrease, or stay the same? It's going to increase. That's right. So the cell voltage increases, and you need to justify that with showing the numbers and showing your understanding of Le Chatelier's principle. Okay? I'm not giving you the full worked out test correction there. I want you to use your words. Okay, let's look at the next question. We have an electrochemical cell consists of a tin electrode. Now, a tin electrode would be a solid piece. And so you're not using all 3 of these equations, you're using 2 of them. You find the solid, and I do apologize, that should have been AQ. Anytime you have ions, that's always AQ. So hopefully that didn't throw you off. If you used all 3 equations, you missed it, okay? But you're using the tin electrode, which is not going to have any ions at all. So this is the equation you're going to use along with the silver equation, both of those. Okay, so it's connected by a salt bridge. Write the equation for the half cell occurring at each electrode. Indicate which half reaction occurs at the anode. So you have to think, which one am I going to flip? Those are your 2 equations. So the one that you flip is going to be at the anode. The one that stays the same is going to be at the cathode. So you had to choose the correct 2 equations there. All right, I'm going to let you finish working that one out yourself. And then B, write the balanced chemical equation for the overall spontaneous cell reaction that occurs when the circuit is complete. So honestly, guys, now that you have the 2 correct equations, you can finish that one out. I think that was the last question. Yes, it was. Okay, so do your test corrections, and remember those are due on Friday. And I will see you guys next time.